March 7th, 1942. Captain Minoru Genda stood in the wardroom of the carrier Akagi, somewhere in the waters south of Java, holding a document that would never be filed in any official record. The paper contained a single directive from Admiral Isoroku Yamamoto, Commander-in-Chief of the Combined Fleet. The order was unusual, perhaps unprecedented in the history of naval command. It forbade all officers under Yamamoto's authority from discussing, in any official capacity, what American factories might be producing. Specifically, it prohibited any mention of automobile manufacturing facilities in Detroit, Michigan. Genda read the directive twice. He had served under Yamamoto for years. He had helped plan the attack on Pearl Harbor. He understood his commander's thinking better than most officers in the Imperial Japanese Navy. But this order made no tactical sense. Intelligence about enemy production capacity was essential for strategic planning. Understanding what ships, aircraft, and weapons the Americans could build determined how Japan should allocate its own limited resources. Why would Yamamoto ban discussion of the very information that shaped operational decisions? The answer, Genda would later understand, was not about intelligence gathering. It was about morale. Yamamoto had seen something during his years in America that he believed would destroy Japanese fighting spirit if widely known among the officer corps. He had witnessed American industrial capacity operating at scales that made Japanese production look like cottage industry, and he had calculated with terrible precision what would happen when that capacity converted fully to military production. The specific trigger for Yamamoto's directive had occurred weeks earlier, in late February 1942. A junior intelligence officer had submitted a routine report analyzing American aircraft production based on intercepted communications and neutral observer accounts. The report mentioned that Ford Motor Company was constructing a facility near Detroit specifically designed to mass-produce heavy bombers. The plant, located in Willow Run, Michigan, was being built to manufacture B-24 Liberator bombers using automotive assembly line techniques. The report included preliminary estimates. Ford engineers claimed they could produce one complete B-24 bomber every 63 minutes once the facility reached full operation. The junior officer who compiled the report had assumed this was American propaganda or a translation error. No industrial facility could manufacture a 4-engine heavy bomber in approximately 1 hour. The B-24 was a complex aircraft. It had a wingspan of 110 feet. It weighed 36,000 pounds, empty, 65,000 pounds, fully loaded. It required 4 engines, each producing 1,200 horsepower. It carried a crew of 10 men. It was equipped with 10 50-caliber machine guns and could deliver 8,000 pounds of bombs to targets over 2,000 miles away. Japanese aircraft factories required approximately 15,000 man-hours to build a single twin-engine bomber. A 4-engine heavy bomber would presumably require substantially more time and labor. The idea that American workers could assemble such an aircraft in 63 minutes seemed absurd. But when the report reached Yamamoto's staff, no one laughed. Senior officers who had served in America or studied American industry did not dismiss the estimate as impossible. They understood what automotive assembly line production meant. They had seen what American manufacturing could achieve when properly organized. Yamamoto himself had visited American automobile factories during his time at Harvard from 1919 to 1921. He had not gone to Detroit, but he had studied detailed reports about Ford's Highland Park plant and the River Rouge complex. He understood that Henry Ford had revolutionized manufacturing through systematic application of interchangeable parts, specialized labor, and continuous flow production. A Model T automobile in 1920 required 93 minutes of labor to assemble. Ford's plants produced over 1 million vehicles annually using these techniques. The cars were mechanically reliable, functionally identical, and inexpensive enough for average workers to afford. Yamamoto had recognized immediately that these same techniques could be applied to military equipment. An assembly line that could build automobiles could build tanks, a factory that produced trucks could produce armored vehicles, and a manufacturing system that made civilian aircraft could, with modification, produce military bombers at rates no traditional aircraft factory could match. The question was not whether American industry could build one bomber per hour. The question was how many production lines they would establish and how quickly they would reach maximum output. The February intelligence report suggested Ford was building a facility specifically designed for mass production of a single aircraft type. This was the key insight that separated American industrial thinking from Japanese approaches. Japanese aircraft factories produced multiple types of planes simultaneously. Different models shared some facilities and workers. Production runs were relatively small. Each aircraft type required specialized knowledge and custom fabrication for many components. The system produced high-quality aircraft, but in limited quantities. American automotive manufacturers approached the problem differently. They designed production systems around a single product manufactured in enormous quantities. Every component was standardized. Every manufacturing step was optimized. Workers specialized in specific tasks they repeated thousands of times. The entire factory operated as an integrated machine designed to produce identical units continuously. When Yamamoto read the report about Ford's bomber plant, he understood what it meant. The Americans were not simply building another aircraft factory. They were creating a weapons production system based on principles that had already proven devastatingly effective in civilian manufacturing. And if Ford could build B-24 bombers at the rate their engineers claimed, then other automotive manufacturers could do the same with other aircraft types. Yamamoto called a meeting of his senior staff officers. He asked them to calculate what American bomber production might reach if Ford's Willow Run plant achieved its stated goals and if other automobile manufacturers built similar facilities. The mathematics was straightforward, but the results were horrifying. If Ford could produce one bomber per hour and operated 2 shifts daily, that single plant could manufacture approximately 16 bombers per day, or nearly 5,800 bombers annually. If General Motors, Chrysler, and other automotive manufacturers built comparable facilities for other aircraft types, American industry might produce 20,000 to 30,000 combat aircraft per year from automotive assembly lines alone, separate from traditional aircraft manufacturers. Japanese industry in 1942 was producing approximately 5,000 aircraft annually total, including trainers and all other types. Even if Japan somehow tripled production, which was impossible given material constraints, America's automotive industry alone could produce more combat aircraft than Japan's entire industrial capacity, and this calculation did not include Boeing, Douglas, Lockheed, Consolidated, or any other established aircraft manufacturers. It represented only what automobile companies might contribute to military production. One of Yamamoto's staff officers, a commander who had studied engineering at MIT in the 1930s, pointed out additional implications. The B-24 Liberator had longer range than any Japanese bomber. It could carry heavier bomb loads. It was better armed for defense against fighters. If American factories produced these aircraft in the quantities Ford's plan suggested, Japan would face bombing campaigns of intensity beyond anything yet experienced in warfare. Japanese cities, built primarily from wood and paper, would be exceptionally vulnerable to incendiary attacks. Industrial facilities could be systematically destroyed. Ports could be rendered inoperable. The merchant fleet that sustained Japan's economy could be hunted to extinction. Yamamoto listened to the analysis without interruption. When his officers finished, he sat silently for several minutes. Finally, he spoke. The information in the intelligence report was probably accurate, he said. American automotive engineers did not make claims they could not fulfill. If Ford stated they could build one bomber per hour, they would eventually achieve that rate or exceed it. But this information must not circulate widely among the officer corps or enlisted men. Japanese sailors and pilots were fighting with exceptional courage and skill. Their training was superior to American counterparts. Their tactical abilities were outstanding. Their willingness to sacrifice was absolute. These advantages had produced remarkable victories across the Pacific and Southeast Asia in the war's first months, but courage and skill could not overcome industrial mathematics indefinitely. If Japanese officers understood the true scale of American production capacity, they might lose confidence in ultimate victory. Morale would deteriorate, fighting effectiveness would decline, the war would be lost psychologically before material factors made defeat inevitable militarily. Therefore, intelligence about American industrial capacity would be restricted to the absolute minimum number of officers who required it for strategic planning. Reports about automotive factories producing military equipment would not be widely distributed. Discussion of American production rates would be discouraged in official settings, and any officer who spread defeatist rumors about unstoppable American industrial output would face disciplinary action. The directive Genda held in the Akagi wardroom was the formal implementation of this policy. It was marked for distribution only to carrier division commanders and senior staff officers. It ordered them to maintain strict control over industrial intelligence and to prevent discussion of American production capacity among junior officers and enlisted personnel. The order was practical from a command perspective. Commanders needed to preserve fighting spirit among their men, but it also represented a profound admission. Yamamoto was acknowledging that accurate information about the enemy's capabilities was too psychologically damaging to share widely with Japan's fighting forces. The irony was that Yamamoto's assessment of American industrial capacity was entirely correct. Ford's Willow Run plant would eventually exceed even the optimistic estimates in the February intelligence report. But in March 1942, when Yamamoto issued his directive, the plant was still under construction, and many observers doubted it would work as designed. The concept seemed too ambitious. The scale was unprecedented. Critics argued that aircraft manufacturing required skilled craftsmen, not assembly line workers. They claimed that automotive production techniques would not translate to complex military equipment. Henry Ford disagreed. He was 78 years old in 1942, irascible, difficult, and absolutely convinced that his manufacturing principles could be applied to any product. When the Army Air Corps approached Ford in 1940 about producing aircraft, he initially refused. He would not build planes designed by other companies, he said. If Ford Motor Company entered aircraft production, they would design their own planes using proper mass production techniques. The government was not interested in Ford designing aircraft. They wanted production capacity. They needed established designs manufactured in quantities beyond what existing aircraft companies could achieve. Charles Sorensen, Ford's production chief, convinced Henry Ford to reconsider. Sorensen had run Ford's manufacturing operations for decades. He understood assembly line production better than almost anyone in American industry. He believed automotive techniques could absolutely be applied to bomber production, but only if the factory was designed specifically for that purpose. Existing aircraft plants had grown organically. They were adapted from older facilities. They were constrained by available buildings and infrastructure. They could not be optimized for single product mass production. Sorensen proposed building an entirely new facility designed from first principles to manufacture B-24 bombers using true assembly line techniques. The proposal was ambitious to the point of seeming fantasy. The building would be over 3,000 feet long, more than half a mile of continuous manufacturing space under one roof. It would employ over 40,000 workers at peak operation. It would integrate sub-assembly production, final assembly, and testing in a continuous flow process. Aircraft would move through the factory on assembly tracks, with workers and parts brought to the planes rather than planes being moved to workstations. The entire building would function as a single integrated machine, producing identical products continuously. The government approved the project in January 1941, 11 months before Pearl Harbor. Construction began in April. The site was farmland near Ypsilanti, Michigan, between Detroit and Ann Arbor. It was chosen for flat terrain, proximity to automotive suppliers, access to rail transportation, and availability of labor. The building design was revolutionary. The main assembly hall was 3,500 feet long and 300 feet wide. The roof was supported by massive concrete columns that allowed unobstructed floor space. Overhead, cranes could move materials anywhere in the facility. The building enclosed 67 acres under one roof, making it the largest room in the world by floor area. Sorensen designed the production process to mirror automotive assembly. The B-24 would be broken down into major subassemblies: wings, fuselage sections, tail assemblies, engine mounts, each manufactured separately, then brought together for final assembly. Every component would be built to precise specifications, ensuring interchangeability. Every manufacturing step would be optimized to minimize time and labor. The goal was to reduce the bomber to a series of standardized operations that could be performed by workers with minimal aircraft experience. Traditional aircraft manufacturers were skeptical. Consolidated Aircraft, which designed the B-24, doubted that Ford's approach would work. Aircraft manufacturing required skilled sheet metal workers who could fit and adjust components to achieve proper alignment. Assembly line production assumed perfect interchangeability, but aircraft were too complex for true interchangeability. Tolerances were too tight. Variations between individual planes were inevitable. Skilled workers were needed to accommodate those variations during assembly. Ford's engineers rejected this thinking entirely. If components did not fit perfectly, the solution was better tooling and tighter manufacturing controls, not skilled, labor-making custom adjustments. Every part should be manufactured to specifications that guaranteed fit without modification. This required investment in precision tools, careful quality control, and systematic process management. But once achieved, it enabled workers with basic training to assemble complex equipment reliably and rapidly. The first B-24 rolled out of Willow Run in September 1942, 6 months after Yamamoto issued his directive banning discussion of Detroit production. The aircraft had problems. Components did not fit properly. Assembly procedures needed refinement. Workers were still learning their jobs. Production was slow and inefficient. Critics claimed the experiment had failed. Assembly line techniques could not produce combat aircraft. Ford should abandon the project and convert the facility to conventional manufacturing. Sorensen refused. The problems were normal for any new production system, he insisted. They would be resolved through systematic analysis and continuous improvement. The assembly line would work once processes were properly optimized and workers gained experience. He was correct. By late 1942, production was increasing steadily. By early 1943, Willow Run was producing dozens of bombers monthly. By mid-1943, production exceeded 100 aircraft per month, and by 1944, the plant achieved the production rate that had seemed impossible when first proposed. One B-24 bomber completed every 63 minutes. The final production rate actually exceeded this figure. At peak efficiency, in 1944, Willow Run completed a bomber approximately every 58 minutes during operating shifts. The plant ran 2 shifts daily, producing over 30 aircraft per day when operating at maximum capacity. Annual production from the single facility exceeded 9,600 aircraft in 1944. This was more combat aircraft than Japan's entire aviation industry produced that year across all types: trainers, fighters, bombers, and reconnaissance planes combined. The statistics were exactly as devastating as Yamamoto had calculated, but Yamamoto would never know how accurate his predictions had been. He died in April 1943, shot down by American fighters over Bougainville while Willow Run was still ramping up production. When he issued his directive in March 1942, the plant had not yet produced a single flyable aircraft. His order to suppress discussion of Detroit production was based entirely on understanding what American industry could achieve, not on evidence that it had already achieved it. The psychological warfare implications of Willow Run's production were recognized by both sides. American propaganda emphasized the plant's output to demoralize Axis forces and boost domestic morale. Newspapers published photographs of bombers moving down assembly lines. Newsreels showed the massive factory floor. Magazine articles described production techniques in detail. The message was clear. American industry could produce war materials in quantities that made enemy resistance ultimately futile. Japanese intelligence monitored these reports carefully. By late 1943, accurate information about Willow Run's production capacity was available to Japanese military leadership through neutral observers, captured documents, and signals intelligence. The numbers confirmed Yamamoto's worst projections, but junior officers and enlisted personnel did not receive this information. Yamamoto's directive remained in effect even after his death. His successors understood his reasoning. Maintaining morale required controlling access to information that might prove psychologically overwhelming. The deception was not sustainable. Japanese forces encountered B-24s in increasing numbers throughout 1943 and 44. Pilots reported formations of dozens of heavy bombers. Ships under air attack observed waves of aircraft that seemed inexhaustible. Soldiers on Pacific islands experienced bombing campaigns of intensity that seemed impossible given what they understood about industrial capacity. The evidence of American production capacity was visible in every theater, but official explanations attributed American numerical superiority to factors other than industrial output. Officers told their men that America was stripping defenses from other regions to concentrate forces in the Pacific. They claimed American aircraft were mechanically unreliable and poorly maintained. They suggested that American pilots were inadequately trained and relied on numerical superiority rather than skill. Some of these claims had elements of truth. American aircraft did occasionally suffer mechanical problems. Some American pilots were indeed inexperienced compared to veteran Japanese aviators. But the fundamental reality was that American factories were producing combat aircraft faster than Japanese forces could destroy them. The loss rates did not matter. If Japan shot down 10 bombers in a successful defensive action, 20 more appeared the next day. If a carrier raid destroyed 15 aircraft on the ground, 30 replacements arrived that week. The production capacity was overwhelming combat losses by margins that made attrition warfare mathematically impossible. For Japan, the broader implications extended beyond aviation. Ford's success at Willow Run demonstrated that automotive manufacturing techniques could be applied to complex military equipment. Other automobile manufacturers followed Ford's example. Chrysler built a facility near Chicago producing B-29 Superfortress engines. General Motors converted multiple plants to produce aircraft engines, artillery pieces, and armored vehicles. Packard produced Rolls-Royce Merlin engines under license for P-51 Mustang fighters. The automotive industry's contribution to military production eventually exceeded $50 billion, roughly one-fifth of total American war production. This industrial mobilization created material advantages that shaped every aspect of the Pacific War. American forces could replace losses that would be catastrophic for Japanese units. Ships damaged in battle returned to service after repairs in weeks rather than months. Aircraft shot down were replaced faster than crews could be trained to fly them. Ammunition was expended freely rather than rationed carefully. The material abundance changed tactical thinking. American commanders could accept higher loss rates because replacement equipment was always available. Japanese commanders had to preserve scarce resources, limiting operational flexibility. The contrast became stark during the carrier battles of 1944. At the Battle of the Philippine Sea in June, Japanese carrier forces launched everything available in desperate attempts to inflict damage on American task forces. American carriers launched strikes while holding substantial reserves for defense and follow-up operations. When Japanese pilots failed to return from strikes, those crews were permanently lost. When American pilots were shot down or ditched at sea, submarine rescue operations recovered many of them for return to service. The material and human resource advantages compounded each other. By late 1944, Japanese military leadership privately acknowledged that the war was lost. Production capacity made continued resistance militarily futile. But surrender was politically impossible. The military government had committed the nation to total war. Acceptance of defeat meant personal dishonor for military leaders and potential prosecution for war crimes. So, fighting continued despite certain knowledge that victory was impossible. The industrial mathematics that Yamamoto had calculated in the 1920s played out exactly as he predicted. The war, Japan could win in 6 months if fortune favored aggressive operations became unwinnable once American industry fully mobilized. Intelligence assessments compiled after Japan's surrender revealed how thoroughly Japanese leadership had understood their situation. Documents from late 1944 and early 45 showed that senior officers recognized the mathematical impossibility of victory. They knew American production exceeded Japanese capacity by factors of 5 to 10 across most categories. They understood that destroying American equipment faster than factories could replace it was impossible, but this information remained classified. Common soldiers and junior officers continued fighting with inadequate information about the strategic situation. The policy Yamamoto established in March 1942 remained in effect until Japan's surrender in August 1945. Discussion of American industrial capacity was restricted to senior leadership. Intelligence about production rates was classified at the highest levels. Reports about facilities like Willow Run were not distributed to field commanders. The censorship was maintained because accurate information about enemy capabilities was deemed more dangerous to morale than continued tactical defeats in battle. This created a strange duality in Japanese military culture. During the war's final year, senior officers knew the war was lost because industrial production made victory impossible. Junior officers and enlisted men believed the war could still be won through sufficient sacrifice and dedication. Kamikaze attacks emerged partially from this information asymmetry. Pilots who understood that conventional tactics could not overcome American material superiority might accept suicide missions as the only remaining option. But pilots who believed Japan still had a chance at victory might not have volunteered for certain death. The mathematical realities Yamamoto feared became public knowledge only after surrender. When occupation forces examined Japanese industrial facilities, the production gap became undeniable, even to common soldiers who had been isolated from accurate intelligence. American technical teams documented Japanese aircraft factories, steel mills, and shipyards. The inspections revealed industrial capacity that was sophisticated in design but tiny in scale compared to American equivalents. Japanese engineers had developed innovative techniques and high-quality products, but total output was constrained by limited resources, small facilities, and labor shortages. The comparison between Willow Run and Japanese bomber production illustrated the gap starkly. Japan's largest aircraft manufacturing facility was Nakajima's Musashino plant near Tokyo. At peak production, Musashino employed approximately 24,000 workers and produced approximately 150 aircraft monthly across multiple types. Willow Run employed 42,000 workers at peak and produced over 500 B-24s monthly during maximum production periods. A single American facility outproduced Japan's largest aircraft plant by more than 3 to 1 while manufacturing a heavier, more complex aircraft type. The resource disparity extended to every category of military production. American shipyards launched more tonnage in 1943 than Japan built during the entire war. American steel production exceeded Japan's by ratios exceeding 10 to 1. American petroleum production was literally 100 times greater than Japan's domestic output, plus all captured resources. The numbers were overwhelming, but more importantly, they were predictable. Yamamoto had understood these ratios 20 years before the war began. His observations in America during the 1920s provided sufficient information to calculate what would happen when American industry mobilized for total war. The directive he issued in March 1942 was an acknowledgement that this information was too psychologically devastating to share widely. Better to let Japanese forces fight without full knowledge of the strategic situation than to demoralize them with mathematical proofs of inevitable defeat. The policy failed in its ultimate objective. Japan lost the war despite maintaining morale through information control, but it may have prolonged resistance. Soldiers who understood the true industrial situation might have surrendered earlier. Pilots who knew the production mathematics might have refused kamikaze missions. Civilians who recognized the material disparity might have demanded negotiated peace before cities were destroyed by firebombing. The human cost of information control was substantial. Hundreds of thousands of Japanese soldiers died in battles that senior leadership knew were strategically futile. Millions of civilians suffered through bombing campaigns that might have been avoided through earlier surrender. The atomic bombings of Hiroshima and Nagasaki occurred partially because Japan's military government refused to acknowledge the mathematical impossibility of victory, even when that information was clearly understood at the highest levels. Yamamoto's March 1942 directive represented a choice between two failures: share accurate information about American industrial capacity and risk destroying fighting morale, or suppress that information and allow forces to continue fighting under false assumptions about strategic possibilities. Yamamoto chose suppression. His successors maintained the policy. The result was a war that continued 18 months longer than industrial mathematics suggested was rational, sustained by soldiers and civilians who fought without complete information about the strategic situation they faced. The lessons extended beyond World War II. Information control became a standard feature of authoritarian military systems. Soviet forces in Afghanistan operated under similar restrictions, with accurate information about military situations restricted to senior leadership, while common soldiers fought without full knowledge of strategic failures. Iraqi forces during the Gulf Wars experienced comparable information asymmetry, with leadership understanding the hopelessness of resistance, while enlisted personnel continued fighting under false assumptions about capabilities and prospects. The psychological impact of industrial warfare on military morale remains a fundamental challenge for nations with significant production disparities. How does a country with limited industrial capacity maintain fighting spirit when facing an enemy that can outproduce them by factors of 5 or 10 to 1? Yamamoto's answer was censorship. Restrict information, control intelligence distribution, prevent accurate understanding of enemy capabilities from spreading beyond minimum essential personnel. The approach failed strategically but succeeded tactically. Japanese forces fought effectively throughout the war despite impossible strategic mathematics. Whether this justified the human cost remains debatable. This specific focus on Detroit production in Yamamoto's directive was revealing. He did not ban discussion of American shipyards, steel mills, or oil fields. He specifically prohibited mention of automotive factories producing military equipment. This suggested that automotive mass production represented something qualitatively different from conventional manufacturing in Yamamoto's understanding. Traditional industry could be bombed, blockaded, or disrupted. Assembly line production was different. It was systematic, scalable, and incredibly difficult to stop once established. A conventional aircraft factory could be destroyed by bombing, halting production until facilities were rebuilt. An automotive assembly line could be dispersed across multiple buildings, with sub-assembly production separated geographically from final assembly. Destroying one facility might reduce output, but would not halt production entirely. And the production techniques were transferable. If one plant was destroyed, another could be built using the same principles. The knowledge of how to mass-produce complex equipment could not be eliminated through military action. This may have been what Yamamoto feared most. Not simply that American factories were producing vast quantities of war materials, but that the production system itself was robust against disruption and infinitely scalable. Japan could not bomb Detroit. Even if somehow Japanese forces reached American territory, destroying Ford's Willow Run plant would not eliminate the knowledge and techniques that made it possible. Other facilities would be built. Production would continue. The industrial capacity was not dependent on any single factory or location. By contrast, Japanese industry was concentrated and vulnerable. Most aircraft production occurred at facilities near Tokyo, Nagoya, and Osaka. Bombing these plants, which American B-29s would do extensively in 1945, could cripple Japanese aviation output. There were no dispersed alternatives. Japanese industry could not simply relocate production to other regions because the skilled labor, infrastructure, and supply networks were geographically fixed. The asymmetry was total. American production was distributed, scalable, and robust. Japanese production was concentrated, limited, and vulnerable. This meant that even successful Japanese attacks on American facilities would have minimal strategic impact, while American attacks on Japanese industry would be devastating. The production warfare was mathematically unwinnable for Japan, regardless of tactical successes. Yamamoto understood this. The March Directive was his attempt to prevent that understanding from spreading throughout the Japanese military, where it might destroy the will to fight before fighting became strategically necessary. Whether Yamamoto's approach was ethically justified remains contested among historians. Some argue that military commanders have a duty to provide accurate information to forces under their command. Soldiers fighting without understanding the strategic situation cannot make informed decisions about sacrifice and risk. Others contend that commanders must preserve morale by any means necessary, including controlling access to psychologically damaging information. Perfect intelligence would paralyze forces facing overwhelming odds. Some level of ignorance may be operationally necessary. The debate reflects broader questions about information, morale, and military effectiveness that remain relevant today. Modern military forces operate with unprecedented access to information through digital communications and satellite reconnaissance. Controlling what soldiers know about enemy capabilities has become more difficult, but the psychological challenge remains unchanged. How do military forces maintain effectiveness when facing enemies with substantial material advantages? The answer may still involve some level of information control, though the mechanisms have evolved from Yamamoto's classified directives to more subtle forms of emphasis and interpretation in intelligence briefings. Ford's Willow Run plant continued operating after World War II ended, though bomber production ceased in 1945. The facility was briefly considered for automotive production, but was deemed too large for practical use. Kaiser Frazer Automobile Company used part of the building for car manufacturing from 1947 to 1953. General Motors purchased the property in 1953 and used it for parts production and transmission manufacturing for decades. The building was partially demolished in 2007, with only a small section preserved as a museum. The site that produced nearly 9,000 heavy bombers during World War II is now largely empty land, reverting slowly to the farmland it replaced. The B-24s manufactured at Willow Run served throughout the Pacific and European theaters. They flew bombing missions against Japan from bases in China, India, and eventually the Mariana Islands. Japanese forces encountered these aircraft frequently from 1943 onward. Pilots who survived combat against B-24 formations reported the aircraft's impressive defensive armament and ability to absorb damage. But they typically had no knowledge of where the bombers were manufactured or how many were being produced monthly. The industrial intelligence Yamamoto restricted remained classified throughout the war. After Japan's surrender, when occupation forces provided detailed briefings about American industrial production, Japanese officers who had fought throughout the war expressed shock at the production figures. They had known American material superiority was substantial. They had not understood the actual ratios. The information proved what Yamamoto had calculated in the 1920s and tried to suppress in 1942. Industrial mathematics determined modern warfare's outcome more decisively than tactics, training, or courage. Japan lost the Pacific War in Detroit, assembly plants, and Texas oil fields years before Pearl Harbor was attacked. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.